This session we discuss about parallel and perpendicular lines. So parallel lines are lines of this form. Or we can have or we can just have this. So these are pairs of parallel lines. So assuming that this is having gradient M1, this other one has having gradient M2, M1, M2, M1, M2. Then for each pair, these parallel lines M1 equals to M2, i.e. parallel lines have the same gradients. So that leads us to an example. So example 1, find an equation of the line passing through the point -2, 3 and parallel to the line (3x minus 6y) equals to 14. So solution. So this, like, we have this in the case where this line passing through -2, 3 and is parallel to this line 3x minus 6y equals to 14. So what we are going to do is to rewrite this equation in the form y equals to mx plus c so that we know its gradient. And once we know the gradient of this line, it will be the same as the gradient of this other line because the two are parallel. So this will be 6y equals to 3x minus 14, which implies y equals to 3 over 6x minus 14 over 6. So y equals to 1/2 x minus 7 over 3. So i.e. m1 is the same as 1/2. That's the gradient of this line. It's like m1 equals to 1/2. And for parallel lines, m1 equals to m2, which will give us 1/2. So m2 here is 1/2. Now we have a point and the gradient. So we have point -2, 3 and gradient as 1/2. So the point intercept form, the point form of a line is y minus y1 mx minus x1. So which will be y minus 3 equals to 1/2 into x minus minus 2. So which will be y minus 3 is 1/2 x. Now minus minus is plus, 2 times 1/2 is +1. So which implies y equals to 1/2 x plus 1 plus 3, that is y equals to a half x plus 4 is the required line. Example 2, write down an equation of the line passing through the point 29 and perpendicular to y equals to 3x plus 4. Now remember, what we are calling perpendicular lines are lines of this form. They meet at 90 degrees. Lines which meet at 90 degrees. So given that, say, this one is line 1, has a gradient m1, line 2, m2, line 1 has a gradient m1, line 2, gradient m2, line 1, m1, and line 2, gradient m2. Then for perpendicular lines, m1 times m2 is -1. So this is a condition. So in our case, we have y equals to 3x plus 4, which means m1 is 3. Now for perpendicular lines, m1 times m2 is -1. So 3 times m2 equals to -1. So m2 will be -1/3. So this means that this other line has the equation, has the gradient. So the line passing through 29 has gradient of -1/3. So using the formula, y minus y1 equals to m into x minus x1, we'll have y minus 9 equals to -1/3 into x minus 2, which will be y equals to then plus 2/3 plus 9. So this will be y equals to -1/3 x plus 29/3. So this is how we solve that question. Thank you.